In this video, we're going to use something called the divergence test to see if we can tell really quickly whether a series is divergent or not. Let's talk about where the divergence test comes from. So we have a theorem that says if an infinite series converges, then the sequence must go to 0. Now the reverse does not necessarily hold. We cannot say if this series goes to 0, then it converges. But what we can say is if this sequence does not go to 0, then we can say the series diverges, because if the series does not go to 0, then we'll always be adding something on that infinite sum, so the sum cannot converge. So let's see how we use this. So let's take our first example here. What we can do is we'll take a look at the limit as n goes to infinity of just this piece. Forget about the summation. So k over, I guess not n, k, excuse me, k over k plus 1. Well, we could use L'Hopital's here. We've got an infinity over infinity case, so we'll do all the steps on this one. So we have the limit as k goes to infinity. Some of you might already know what the limit is. Derivative of k with respect to k is 1. Derivative of the denominator is 1. So this limit goes to 1, which is not 0. So we can clearly say this diverges by the divergence theorem. Let's just say by divergence theorem. Use a lot of acronyms just to save a little bit of time when we're working with series. Let's go to B. We're going to look at the limit as k goes to infinity of -1 to the k. Well, this is an interesting one, because if k is odd, then it's -1. If k is even, it's 1. Well, if k goes to infinity, we can't put down that it's -1 or 1, so this does not exist. If it doesn't go to 0, then the series diverges. Misspelled that a little bit. Diverges by the divergence test, or divergence theorem, some people call it. Our last one, we have the limit as k goes to infinity of 1 over k. Now this does equal 0. That is not enough to say that the series converges. That's very important. What it tells us, though, is that we are going to need to run another test to see whether or not this converges, because what we're going to see as we go on, this is actually going to be a divergent series. We just cannot show it by the divergence theorem.